Right, in this question, we're looking at the rule. The integral of a, so that is base a, to the exponent nx dx equals, so the rule is a nx. So if you have a number, for example, a to the nx, then all you do, you copy all of it and write it in the numerator. So all of this copied in the numerator, and then it'll become n ln a. So that n will go in front in the denominator, so you copy it down, and the base will be ln a. As simple as that. And that's the rule. Right. So that n will be there, and that a will be there. Right. So follow this method for all of them. Don't forget that a must be positive. A is more than 0. So 9.1. We got the integral of base 3 to the 2x. So write it all as it is. Take the exponent, place it in front, ln of the base. So there's the base 3, ln 3. So there's the 2, and there's the 3. 9.2. The integral of 6 to the power 3x. See if you can do this one. Follow 9.1 as your example. Pause the video, try this one quickly. Right, copy all that you see in the numerator, then write your 3, then ln 6 plus c. Okay. Next one, the integral of 5 to the 4x. Copy everything in the exponents. There you have it. 4 ln 5 plus c. Try the next examples. Pause the video. 9.4, 9.5, and 9.9. Try these. See if you can do them. Right. In the numerator, we have 2 to the 5x. And then that value, the 5, will go in front. Okay, so whatever's in front of x will go in front, ln of the base. The next one is very similar. Same thing. Copy all of it into the numerator. Then copy the 5 ln 4. The next one, all of it into the numerator, and then 3 ln 8. Okay, so it uses the exact same method as 9.1, 9.2, 9.3. Exactly. All these are exactly the same. Right, moving to 9.10. Remember now we are using the previous exponent laws. Right? So here we have a to the x ln a. So all we do, we take that base and it becomes ln a, and it's a to the x in the numerator. Then we have the one with the number in front of x, so we copy all of it down, 2 ln a, right? And then 1 over x will be ln x plus c. 9.11, where we have a 1, it will become x, and we copy all of that in the numerator, 2 ln 3. So this is like the examples we were doing in exercise 9 plus c. Right, and that's 9.11. Now we're going to do 9.12. Don't forget e to the x is different. It remains the same. And then we have minus 5a to the 5x. Copy it all of down. Write the 5 because it's in front of x, ln a. Notice that this 5 is not a base. It's a number in front of an exponent, right? So now we'll get minus 6 ln x for 6 over x plus c. We can simplify that. The 5's will cancel each other, and so we'll get a to the 5x over ln a. The 5's killed each other. Minus 6 ln x plus c. Right, so past paper questions. These are some from the past papers. Right, so we have the integral of x to the 4th. Add 1 to the exponent, copy it in the denominator, plus c. Then we have this one, number 2. Notice that there's no x here, so that means all of this is a constant. This means we will add x to it. Then adding 1 to the exponent here, so that's 1 already. 1 plus 1 will be 2. Copy it in the denominator. We'll have x squared over the original 4, and here's the 2 copied in the denominator, and then plus c. So the next step, we can simplify that. We'll get x squared over 8 plus c. Number 3, we're going to multiply the exponents. We're going to get x to the minus 9 dx, right? So it's the integral of all of this. I left out the integral sign. Don't forget, minus 9 plus 1 is minus 8. So the exponent will be minus 8. Copy it to the denominator. You'll get minus 8. Putting the negative in front and moving x to the minus 8 to the bottom, writing it as a positive exponent. This means we'll have to shift that numerator down to the denominator, and that's how we get this x to the 8 being positive. Okay, next example. We have this one, the integral of the first and the integral of the second one. So here we're going to add 1 to the exponent and copy the denominator. We'll get minus x minus 3 x to the 3 over 3 plus, now notice there we have 2 over x. So because we have 2 and x to the minus 1, that's equivalent to 2 over x. So that will give us 2 ln x plus c. Number 5. Notice here you have 2 binomials. You will have to multiply these binomials out until you get a trinomial. So in other words, using the FOIL method, this is what you'll get. Then it's the integral of each term. Right, so if you apply the integral to all those terms, this is what you will get next. Adding 1 to the exponents, we'll get x to the 3rd over 3. Then the next one, we will add 1 to the exponent there, so it'll give us x squared over 2, and obviously we can simplify that in the next step, and then we have plus 15x. In the next step, we're going to simplify that 8 over 4. It will become a 4. That 8 over 2, it will become 4. Alright, so we have x cubed over 3, and then minus 4x squared plus 15x plus c. Right, it's as simple as that. Right, so number 6, we're going to apply the integral to x squared and the integral to y squared. Notice that it's dx, so we're carrying out the integration on the x's. So adding 1 to the exponents, we'll get x third over 3 plus x in front of the y squared. Right, and that's our final answer. Number 7, the integral applied to each one of those terms. The integral of 2x will give me 2x to the 3 over 3. And then for the next one, we'll have a half ln x. So do notice we have 1 over 2 in front, which is a half ln x. The next one is exponent minus x to the half. Right, so adding 1 so notice that this is a square root of x, so it's x to the half. Adding 1 will get x to the 3 over 2, copying it into the denominator. Then the next one, we'll copy all of the 4 to the 3x in the numerator, and carrying out integration on that, we'll get 3. Remember, the 3 in front of x will be brought down to the front, ln 4. So 3 ln 4 plus c. Right, do note an error over there. I made a mistake. That will become x squared over 2. Right, so notice here there's a 1 in front, so adding 1 to it will become 2. I made a mistake. Right, so here we'll get x squared, the 2's will cancel. We'll get ln x divided by 2, so a half times a number is the same as saying the number times the number divided by 2. And then the next one, don't forget, we have 3 over 2, x to the minus 1. Notice that's in the denominator. Now when we have integrals, a number over number, then this will become 2 over 3. So minus 2 over 3, x to the 3 over 2 as the exponents. And there we have it. Right, and that's our final answer there. Number 8, the integral of 3 over x, that will give us 3 ln x plus c. Number 9, the integral of the first one and the second one. Notice we'll have to separate them first. Right, do note there's a small mistake here. I wrote a 5, that should be a 3. And carrying out integration on that first one, before we start, we'll have to cancel a x in the numerator and cancel a x in the denominator. So take away that x will give us minus 3x over x to the power 4 plus, and converting that to an exponent, there's it to the x to the power 3 divided by 5. So this is 3 over 5. So it's not too clear on the screen, right? And so carrying out integration here, this is actually x to the minus 4. Adding 1 to it will give us x to the minus 3 over minus 3. And then integration here, adding to it, adding 1 to the exponent, as good as adding 5 over 5, which is equivalent to 1. So 3 over 5 plus 5 over 5 will give us 8 over 5. And so our new exponent becomes 8 over 5. And here we have 5 over 8. So whatever you see here, if you put it in the denominator, all you do is you flip it around so that it becomes in front of the term. Right, simplifying this, the minus 3's cancel. We then left with x to the minus 3. Place a 1 over it and now gets a positive exponent. So you'll get 1 over x to the third plus 5 over 8 x to the 8 over 5 plus c. Right, and that is past paper questions. Right, let's consider the very last one, which is f of x is equal to x to the third minus 8. Now notice that is the cubes, the difference of cubes, which means you can factorize that. Now the integral of f of x means, if this is f of x, this means I must substitute x to the third minus 3 where I see f of x, because f of x is equal to all of this. So the integral of f of x, since this is equal to that, means I must take this and place it where I see f of x. So it's the integral of 3x minus 8 placed there. So now I need to factorize that, but that will be here in the step. Right, so this is number 1. So here, when we take the same f of x and place it here, notice we can factorize it first. Alright, but anyway, let's deal with this question. So the integral of x cubed will be add 1 to the exponent and over that same exponent. So adding 1 will give us 4 over 4 minus 8 to the x. Very simple. Now we got the integral number 2. We will have to place that there and substitute it, right? And then we have this in the bottom. Now we can factorize x cubed minus 8, right? It's the difference of cubes, as said before. So factorizing that, how do we do that? Very simple. So we cube root the first term, cube root the second term, and we write it in brackets. So the cube root of x cubed is x, and the cube root of 8 is 2. Now we forget about this on the left and we focus on this bracket. All we do is square the first term and square the last term. So squaring the first term, our focus is on those. Square the first term, we'll get x squared. Square the last term, we'll get plus 4. Notice here it will always be a plus. Then for the middle term, we write the opposite sign of this first bracket. So here's a negative. We now go for the opposite sign, which is plus. Then we multiply 2 times x for the second term. Right, notice that the denominator is exactly the same as all of that, which means those are going to cancel out. We then have the integral of x minus 2. So the integral of x minus 2 will be the integral of x, which will be x squared over 2. And then adding x to the 2 will give us minus 2x plus c. Right? And that is our past papers. Now, look at this just as a reminder. The integral of 1 over x will be ln x plus c. The integral of 1 over x squared. Now notice I can move that up to the numerator. That will become the integral of x to the minus 2. Adding 1 to the exponents, I'll get x to the minus 1. So if I add 1 to the exponent, whatever I do in the top, I do in the bottom. I copy it. So that's going to give me x to the minus 1 over minus 1 right? Bring the negative sign to the front, and that push that x to the minus 1 down. I'll get 1 over x plus c, right? So x to the minus 1. To make this a positive exponent, the method says circle it and push it down. It'll become x to the positive 1, and it will leave the 1 behind. Right, now let's consider the integral of 1 over x to the power 4. See if you can do this one. Pause the video, do try it out. Right, the integral of x to the minus 4. That's pushing it up to the numerator. Now add 1 to the exponents. I'll get x to the minus 3 over minus 3 plus c. Then move the negative sign in front. And then move x to the minus 3 to the denominator. It'll become x to the positive 3, leaving 1 behind. Okay? And copy it. Right? It's good. So we moved this negative to the front, and we copied that minus 3 to the denominator. So notice that minus 3 got copied to the denominator. Next step, we moved the minus in front. Moving x to the minus 3 down to the denominator, we will get this, a positive 3. Notice that was a negative 3. And that is our final answer. Do you see? We moved x to the minus 3 down. It became a positive 3. And that's how we do that. Okay, I hope these examples are good. Do practice them a second lap. These were from the past papers.